Problem 64, minimum path sum. So to solve this problem, we need to know one concept, and that's DP. DP is all about building solutions on top of solutions. So let's see this in action with the problem. So the objective is very simple. We want to get from the upper leftmost corner to the bottom rightmost corner while minimizing the cost needed to get to there. And the cost is denoted by the numbers in each square, and we add them up for each square that we traverse. So how do we solve this problem? Well, when you see a problem that's difficult, condense it into simpler problems. So let's just consider a 1 by 2 case. We consider 1 and 3. Well, how many ways are there to get from this starting position to this ending position? Well, there's only one possible way. We just go right. So therefore, the cost to get to E is going to be equal to 4. Now let's extend the case. What if we have a 1 by 3? 1, 3, and 1. Well, this cost is equal to 4. Then what must this cost be? Remember, there's only one possible route we can take. So this has to be equal to 5. So therefore, we can see that by extension, it can be however many rows, or sorry, however many terms in this array. We're just going to keep summing up the previous cost with the current cost. And we can extend that logic to the columns, right? Which is going to be, for this 3 by 3, it's going to be 2 and 6. So let's actually draw it much more nicely, where each term within the square represents the cost to get to that square. The starting position is always 1, 2, and 6. This is 1, 4, and 5. Now let's consider this position, the middlemost position. How many ways are there to get to this position? Well, we can only go right or down. Therefore, the number of ways to get to this center position is dependent on the number of ways to get to this position and this position. Therefore, the only two possible routes we can take are going to be route 1, where it costs us 2 plus 5, and route 2, which costs us 4 plus 5. And which one of these costs is the minimum most cost? Well, it's 7. Therefore, the ideal way to get to the middlemost position is going to be going from 1 to 4 to 7. And you see where this goes. This position is going to have a cost that's the minimum of 5 plus 1 and 7 plus 1, which is 6, 7, and 4. Or sorry, 7 and 6 with a cost of 2 right here is going to have a minimum of 8. And this is 1. 6 plus 1 is 7, 8 plus 1 is 9, and that's how we arrived at the answer of 7, as we see in the example. So with that, we can program it up in Python. So first of all, we need to know the number of rows and the number of columns. The number of rows is equal to the length of the grid, and the number of columns is equal to the length of the first element within the grid, which is a list. So what can we say? We can say that we need an array to store the cost to get to each position, which has the same number of columns and rows as the grid. So 0 times calls for underscore in range 0 to rows. That's how you initialize the 2 by 2. So now for I in range 0 to rows, we're going to do row major order, j in range 0 to calls. Well, first of all, the cost to get to the starting position is always going to be equal to the original cost. So grid 0, 0. If I is equal to 0 and j is not equal to 0, that must mean that we are on the first row, right? Considering the positions that are not 0, 0. So from our logic, the cost to get to this position at ij must be equal to the cost at grid ij added with the cost to get to it from the previous path, which is going to be j minus 1, like so. If I is not equal to 0 and j is equal to 0, that means we're considering columns. And by the same logic, is equal to grid ij plus the array at I minus 1, j. And what else? If I is not equal to 0 and j is not equal to 0, that means we're in the middle, somewhere in the middle of the grid. The cost to get to this position must be equal to the two possible paths, right? It's the minimum of it. So grid ij plus the upper path, get this out, the upper path, which is going to be the array at ij minus 1, or that's the left path, the leftmost path with the uppermost path, which is ij plus array at I minus 1j. There we go. So and that's the algorithm. So we return the final position, which is rows minus 1, columns minus 1, and we run it, and it passes. So let's submit. And that's the solution.